The next speaker is Lindsay Silver from Condé Nast. So Condé Nast is traditionally thought of by me and by lots of people as like the publisher of Wired and lots of high-end publications. But they're actually going through a transformation. They're moving from being a media company to a technology company. And so Lindsay Silver is at the head of that transformation. And he's going to talk about something very close to my heart as a commercial software company. Revenue engines. We love revenue. Who doesn't love revenue? That's what pays us what we do to do what we do. So Lindsay, welcome on stage.
Thanks, sir. Thanks, guys. So I'm Lindsay Silver. I'm the head of platform engineering at Condé Nast. Until recently, I was the head of data engineering here. And so the talk will sort of skew toward data. And we'll operate at the start in kind of a general format, and then we'll get into kind of an example of how Condé Nast has used microservices to create revenue and create revenue engines. So just to give you guys a little bit more context, Condé Nast is about 100 years old. Which is sort of bizarre to say as a head of engineering, because no one I know and no company I've ever worked at has been more than 5 years old before this, maybe with one exception. So saying that I work at a company that was around when cars were invented is a pretty incredible thing to say. We also have a huge market for our product, right? We're a magazine company. Historically, our magazines are all over the place. Chances are you've seen one today, hopefully outside of our offices. Sitting at a check stand or in someone's coffee table. That's a pretty neat legacy to have behind us. But as everyone knows, and has become a sort of overused statement, print media is dying, right? In theory it is. I think it's plateaued now. I don't think it's actually as drastic as people think. But the idea of print media is going down, and people are consuming more and more media on their phones, on their laptops, on their iPads. So our job as a company is to figure out how to take this and transition it from being a magazine company into being a technology company that creates experiences and creates ways for people to view content online and interact with it. So we've done a pretty good job at that. We have a huge number of global monthly users. These are folks who've viewed one or more articles online, either on our US platforms or internationally. We create a huge amount of content every month. And we have a huge network of authors. So we have all these amazing things, these inputs, let's call them. And our struggle and our job and the challenge that we have now is to take and build technology that leverages these as efficiently as possible. And so I used engines. I know it's overused. I know that everyone has applied that to some part of their infrastructure in the past. I want to break it down a little bit, though, because I think engines is an extremely important concept. We talk a lot about systems and processes and technologies that do things and automation. An engine is a really specific type of process or technology, right? It's a technology that takes some sort of input, endowed with some energy, something of value, and turns that into force or movement. As a technology, you can think of these all over the place, right? Almost any service that you put in an element and receive out a storage, an ID that stores it. That element had sort of transient energy. You're now getting back a version of that that's stored somewhere that allows you to do things with it, right? You're transforming some piece of data into some movement, something that's actionable. At Condé Nast, and one of the reasons I really like the idea of engines is that at a high level, our technology stack as a whole is an engine, right? We need to figure out how to take all of that pent-up energy and all of that content and move it onto the web and allow people to interact to it. That's movement. That's creating revenue. That's creating ways for us to move forward. But as you break that down, and we do this constantly, as we break that down into our editorial platforms, which allow our editors to move that raw content into a digital format, we break down our experience platforms, which allow us to take that content that's been created and move it into a place where people can see it. And start that engagement, or our monetization platforms, which allow us to take that content in its form that's on the web, that's engageable, and monetize on it, to show ads on it, to have people interact with things that we get paid for. All of those are also engines, right? And if we go down a level below that into the services and the technologies that allow those things, we get into structures that are also engines that take an input and create movement or force with the output of that, right? And you can go all the way down to the service level. You can take this and break it down all the way from this top-level giant engine concept all the way down into the microservices that we use to actually drive these platforms. And so today I wanted to start with this. I wanted to break down engines a little bit more and talk to you about how I think about engines. And so I think of them as three types. They actually fundamentally work all the same way. The top and most things that we do are velocity engines, right? Takes an input, runs at a steady state, does an output. You put a bunch of editors on something, they're going to create a set of content, we're going to push it out, and we're going to create experiences on it. It's going to create a set amount of revenue. And we could almost create an equation for that. 10 editors, one website equals, I don't know, $500,000 in revenue, right? We can create that and we can run that. And if we just let it go, as long as the dynamics of the environment didn't change much, we would just keep that running like that, right? And you can do that all the way down to the, to the level of a node application running, one process on one EC2 instance, right? Takes an input at some level, puts an output at some level. The area that I'm really interested in, and I think that technology does, and at a high level, what our technology groups are, our sets of engineers and product managers working on things, we're growth engines, right? We know what the steady state is. We know where we are now. We're trying to change that. So we're trying to create growth and optimization. We've got our websites. We've got our pieces in place now. They're moving at a steady state. How do we increase that? How do we grow that, the value of that? So one piece of content now can be shown to 1 million people, can yield revenue of $100, let's say. What we want to do is move that from $100 to $200 without changing the inputs. Or we want to, in other words, we want to take down the number of inputs to outputs, right? And that's effectively what growth is. We should be able to create $200 per piece of content, 2 million engagements, however you want to look at that. The third type, which is actually something that I think is a little bit trickier to describe, but is really important, are acceleration processes or engines, right? Acceleration engine is when you manage to, in a controlled way, take growth that you've created and accelerate it. And this is what, if you look at what, the stupid VC hockey stick concept, this is what they're talking about, right? They're talking about network effects. They're talking about building acceleration engines. That's something at a 100-year-old content company like ours that we're struggling through, and it's what we're trying to approach now. Is how do we take content? How do we control virality? How do we with technology build systems that actually are self-accelerating, right? And so these types of engines, you can actually apply these. And what I like about this, because I am an engineer by training, is that you can apply these concepts all the way from very technical, specific processes that you're building all the way up to the business. They kind of tie those two things together really well, if you think of them as engines. So there we go. So I want to take you through one growth engine that we built last year. I think growth engines historically for me have been the most interesting thing. How do we move from sort of a simple website content company and a magazine company to a company that is growing and looks sort of more like a startup or looks like a company that's actually approaching technology as an accelerator or a growth factor. So fundamentally, we build content experiences. This is Vanity Fair this morning. If you're a Trump supporter, I'm sorry about that headline, but I thought it was pretty funny. So if you look at this content experience, what we're seeing here is a big piece of content in the center. Usually that's curated by an editor. They decide that piece. Then on both sides, you have what we call rivers of content, which are dynamic. In this case, they're probably hand-curated in the past. Now we're starting to move away. And what I want to talk about is the way that we make the decisions around putting up this page and what content gets shown. So last year, our data technology team started thinking about what are the pieces we need to create a system that allows that is an engine for growth or for improvement of this page. Right now, this page yields, let's say, $100 in revenue per hour or something like that. How do we take that same content, not change the way that our editors interact here, but increase that from $100 in revenue to $200, right? And what we realized is that we needed to build a feedback loop. We needed to build an engine that allowed this page to optimize based on what was happening on it, right? And that fell into two areas. That fell into how the context of the visits that were happening on that page happened. And so that's what content was on the page, what time of day it was, where the visitors were coming from. All of those things are contextual, right? That's contextual data. And then also behavioral data. Who were the people? What can we isolate and figure out who the people are? And if we could feed those into inputs, what we'd like to be able to do is improve, let's see if I can go back here. There we go. Improve the layout of this page, increase the engagement of this page, just by switching around and moving the elements on this page around, right? And so conceptually, this was sort of the product, this was the problem statement, this was our thesis, was that if we can create a system that allows us to measure this data coming in, allows us to analyze this data and then make a decision, then we can change the page in real time. A couple sort of side facts to note. Condé Nast gets between 1 and 2 visits per user per month, which is an interesting paradigm. If you work at a company that has logged in users or is a SaaS platform, chances are you've got orders of magnitude more visits per month. We have a very small number per user, which means that we have to either optimize in real time on the first visit, or we have to, and there's another dynamic here, which is that chances are if you come see one thing, you'll visit a second thing then. You won't actually come back 15 days later to check our platform again just out of the blue. The likelihood that you visit twice after you visited once is extremely high. It's not the likelihood that you visit again later in the month's low. So either we need to make those decisions based on some context really quickly, right, when you come, or we need to make the decisions right after so that we can serve some changes on the second page view that you do there, right? So the system has to be extremely quick. So we've conceptualized this engine. We think of it as a growth engine that does this, that is going to take these things, do some analysis, and make some decisions. And what's cool about it is it's basically a microservice architecture. We have a service here, an event collector service, that at scale is taking in these events and flowing them into Kinesis, doing a little bit of decoration. Its only job, it's a single API endpoint running on a fleet of node boxes that just takes these events, validates them, adds information from a UA string, and a few other properties, geo properties and things like that, pumps them into Kinesis. Once we've got that data in, we can put it all, we can take it all over the place. So we have a real-time stream analysis framework. It's actually 2 of them, one in Storm that allows us to deploy these topologies, one in Druid, which allows us to do roll-ups and do aggregation. And then we're pumping this stuff also into orc files so that we can do offline analysis. Once it's there, once we can get to it, we have a modeling layer with Torch that allows us to actually build to do that analysis, that second section. And what's neat about this, and what we've designed this engine to do, is to allow people to build models and to create new knowledge on the fly, right? So we have a model registration service that holds the concept of a model. It just says, okay, there's metadata around some decision. I've got 1 billion events. I want to look for the ones that are clicks, let's say. I want to look for the users who clicked. I want to roll that up, and I want to score those people based on the topics they clicked on. That may be a model that you register. That comes along, and once it's registered, there's a validation service that any event or any learnings that you get here in this modeling pipeline go through to validate the shape of the data, make sure it's a format that we can actually use in production, and then store it and return it. And so each of these services has a really specific job. And as we talked about, each of these services takes an input and creates movement from that input, right? That it pushes along the surface, especially these ones around the events flow. So the events effectively go from our event collector up here through Kinesis and up to our validation service once they've been rolled up or aggregated, back down and through here, and then to our experience. And that process happens over and over again. And this is where the engine piece comes in, right? This feedback loop means that if I want to, I can actually build in framework or build in models here and pipelines here that expect change from another pipeline, right? And that means that you can say, okay, I want to know people, if I make a supposition, if I've chosen, or if I have a variation testing framework or something that runs off of here, if I see something, I can change in engagement based on a certain variation, I can optimize based on that model over time. And then what happens is and what's happening for us is that this actually, if you turn it on its side, you take this feedback loop, this engine, and you turn it sideways, ends up being an upward spiral, right? We're getting better and better, and we're improving as we go on this process. So we built an architecture that allows us to improve our systems dynamically. And that is the crux of a growth engine, right? That is change. These underlying systems are just working away. They're doing what they do. But every time we get a visit, every time something happens, we increase our value. And there's no additional work to doing that. And that is a growth engine at its whole. To change this into an acceleration engine, and the neat thing about an architecture like this is that the only difference between this and something that might accelerate is a tie-in, is the state of these models, right? So if we were to somehow tie together user behaviors at this model level and create state, it's a fairly computationally heavy process. But if we can do that in real time, then we can actually make things that improve, if these things are all happening in parallel, that add to each other. So one user does something, because we notice that that person did something, we react to another user's pipeline based on that. And that interweaving is effectively the user effect that Facebook and Google have harnessed to some extent. It'll be a slight change, and in the future, we'll actually build around that. It's a heavier process, but it allows us to accelerate, right? It allows us to react to groups of users and the dynamics. This is a fairly simple interface. There are a lot of companies that have built similar things to this. What I think is important here is that we really focused on the pieces. These pieces of the system can be used for all kinds of things. Because they're microservices, because they're one purpose service level or services, we can use things like our event connector and Kinesis to do transactional notifications. We can pump a notification in, filter on a notification type, and actually build a conversational bot on this same set of things. It plugs in, we can use that piece for all kinds of things. Because we have Storm and Druid, this little package can be used for analytics. We have real-time analytics capabilities really easily out of the box with that. And as you go around here, you can see taking certain parts of this one, we do a lot of third-party data analysis. We actually have flows in this level going from sort of out here through that never touch this real-time behavioral data. Because of that, we can recompose these groups of blocks, these microservices and these systems to do all kinds of things. And that's, if you think of those as engines, if you think of those as ways to accelerate your growth, then it becomes really interesting, I think, and that's kind of how we've approached it. So the major technologies, Presto on this side, we obviously didn't build. The rest of these are Condé Nast technologies. Sparrow is our event tracking system. Our Infinity ID, for the first time, allowed us to track people simply with just a simple session or open a session across all of our sites and all of our partners. So we started to see the same behaviors across our 350 million users around the world. That was a huge thing for us. HAL, which is our NLP framework, has come a long way in the last few years, but we've made a lot of investment in being able to extract data from our users. And then 4D, which is that caching mechanism that serves that content back to the pages. So just a couple examples. We'll move really quickly through this. What's happened here is we've started deploying this around our sites. We've put features on our sites that use this. Just in the last 3 or 4 months, that has led to over 10 million additional monthly content engagements. So that was no extra work anywhere else in the system, just deploy this thing. And that's not a huge amount of revenue if you do the math on that yet, but what it does show, and we've deployed it maybe to 1% of the potential areas or even less, is that we can substantially grow just with this technological change. So we've created an engine for growth, for growing these things. And as it gets better, that number increases, right? It's a 12% increase in engagement when we do these things, pretty much across. That's a big variance there. Some of the recirculation widgets are fairly low. Some of the personalized emails and the things that digest and some of the recommendations are amazingly high. We have one digest email that gets over 50% engagement. It's completely automated. People are clicking on things almost every time we send that email, which is pretty amazing. And then people who engage with these experiences are 2 times more likely to do things. So the point of those in this context is just that these aren't human, this isn't part of our steady velocity. This is just a plugin we've added to do growth. This is an engine that accelerates the growth of our systems. These are just a couple examples. We started doing hot linking, automated hot linking on Vanity Fair recently. Anytime we see a person's name in an article, we find that, we extract it, we look at the person who's reading the article to see if they have any interests in that person. If they do, we look at what articles they've read, and then we link them to articles that are similar about that person. That's all happening behind the scenes. But at the end of the day, we have something like 20% more links in our articles, and those are getting a bunch of clicks. We have persistent experiences that we're able to do now. So even if you haven't logged in, we know basically what you've done around the sites. We keep track of that. We know what topics you're interested. We can start recommending things, even for folks who haven't logged in. And then our advanced interaction. So the great thing about something like Sparrow is you can follow regular behavioral events like page views or scrolls, but you can also pump any kind of event in here. So without you doing anything, without you logging in, I can ask you a question and get you to answer, and all of a sudden that data becomes really useful in this engine, right? I can ask you, and Golf Digest is doing this with handicaps. People will indicate their handicap, and then from then on, we're tuning their experience based on their handicap. We're not going to show a beginner golfer a bunch of articles about how to chip in an angle or something. I'm not a good golfer, so. But those things are amazing. So, and there are dozens of other applications of this, but it's based on that idea that we can create these engines that allow us to do these things more quickly or more effectively. So just in summary, so microservices are great because they're very simple. They take one input, they create output, right? One thing that can cause trouble, and I think this is a fundamental rule of microservices anyway, but separation is really important. You want to decouple processes, and that's important within these types of engines as well. It's really easy to say, well, I have this really cool recommendation service. Maybe I should combine it with some sort of feedback mechanism, and then I'll build it, so that it optimizes itself within the service. That's good. But chances are that the generalizing what you're trying to do with that acceleration actually has more than one application, and it keeps your services really simple. So having a secondary service that takes that requests that recommendation, takes user data, formulates a better request for your recommendation service based on that data, hits that service, and pulls back in a personalized result, and then serves it back to the user, is actually a way more efficient way, because there may be other applications of that user or of that data, and you can expand that service more effectively. So growth engines are very generalizable, right? So auto-scaling is a really good example of a growth engine. It basically makes processes more efficient. You don't have to run the maximum number of servers you need for your spikes. You can auto-scale based on those, right? If you built that into the services themselves, so if you somehow said, okay, every one of my microservices should know to trigger something when it needs to scale, or when it's at some CPU level or at some threshold, then you have to go through and do that with every single one of the things you do. If you separate auto-scaling into a generic service of its own, and obviously now it's just a bunch of buttons on your AWS account, but if you separate that concept into its own application that's generic and knows how to watch these things, it becomes way easier to scale and to use. Chaining engines together, sort of like I described, is actually really powerful in a microservices world, right? You could actually build chains of these engines that will, the output of the third one or fourth one is based on the outputs of the ones before, and you get into sort of a topology model similar to what Storm or Spark uses to actually drive systems of processes. That's a good model when you can decouple these things so that you can use any of them separately, but that they build on each other. That's a very good pattern for these types of services. Effectiveness is tricky to measure, especially with these compound growth services. And so what I generally do is measure effectiveness as the volume of inputs to the value of outputs, right? And that can be subjective in and of itself. But it's a fairly generic way to conceptualize how to measure the value of a technology or a process that's considered an engine. And then the last one's tricky, but it's important. Users should always see these engines as velocity engines. They should always see them as just a standard part of doing business. They should never think of what they're doing specifically as growth, because then they get really frustrated when growth fluctuates or changes, right? You should so when you're building a service, you should always treat it as a simple service. You should say, okay, this is our recommendation or framework. Underneath the covers, you may have built in growth into that, and you may expect people to see that growth. But you don't want to say, okay, this is our engine for growth, or this is accelerating things, because then people start to think, okay, well, why aren't we doing this everywhere, and why isn't it working today, or why isn't it working? So controlling these under the covers, and we can talk more about that, but treating everything as a velocity engine on the service, just treating these as normal processes in your day-to-day world, actually gives you a lot more flexibility. So I think that's it. I'm happy to answer questions. I'm not sure if we have much time, but does anyone have questions? Cool. Well, that was easy then. Awesome. Oh, yeah.
The model creation, it sort of kicks off the whole thing. Can you talk a little bit about who's doing that and how that's happening?
Yeah, so we have a data science team. We have two, so we draw a pretty strict division between contextual data or content data and user data and user modeling. And so we have two separate data science teams that focus on those. When they come together into behavioral models, generally our data science team focused on users does those models. And so they're building user attributes. We have a topic preference model that we've constructed, which is a real-time model that watches user behavior. It looks at the structure of topics that our NLP teams built, and then combines that. That would be the responsibility of the user data science team. And we've seen, and I don't know if you guys, I mean, a lot of you have probably seen this, but these types of processes of building these predictive models is getting amazingly simple and amazingly available, right, to third parties. So with Clarify, we just saw a demo from Microsoft that's similar. A lot of companies are focused on how to make this type of modeling easier. The great thing about this type of process is that external APIs or external models plug right into it, right? You just need, you're basically creating a simpler framework internally for taking those API results, plugging them back into your engine or your flow. Cool. Any other questions?
So
Yeah.
Sorry, shoot there.
Okay.
The audience comes first.
Yeah.
So your content is now able to like basically reflow itself, and the page almost gets a complete redesign from what it looks like. What kind of constraints does this put onto the content producers, and have you seen general like acceptance of those constraints or resistance as you push this down into journalists?
It's a really good question. So we're really early in this process, and so generally we focus on low-value areas of the site. So these sidebars or below the fold type content is usually the editors have less sort of focus on it. What we've discovered is one of the tricks to getting through this is to say to editors, look, we're not going to just pick from a random bag of content. We're not going to go out there and look at 20 years of Vanity Fair content and try to find the best stuff to show here. We're going to allow you to choose the pieces that appear in this river. We're just going to arrange them for you, and that gets people to relax a little bit about it.
Thank you.
Cool.
So one quick question from me. So this is, Condé Nast is becoming a technology company. Are there any plans to open source any of these components?
Yeah, so we've started a fairly aggressive open sourcing strategy, which is in its early days, and Gautam, who's one of our architects, can probably talk to anyone more about that offline. The pieces of the system, so a lot of the great thing that we've done is taken a lot of commoditized pieces in a lot of cases, so either open source projects or other things to use. The pieces that are fairly proprietary, like HAL, which is our NLP framework, we do have plans to open source. And so HAL, we're thinking about, Sparrow, we're thinking about open sourcing, and then some of the higher level pieces.
Great. Good to hear.
Yeah, cool.
Thanks very much, Lindsay.
Thank you all.
So I think the key message from Lindsay's talk, which I love, is tie what you're doing to end user business goals. If you can't move the needle for the business, then what are we doing here? Software must have an end purpose in mind, and that end purpose for most people who are building commercial software is to move the business goals of the organization. And I think we've seen some excellent examples in Lindsay's talk of how they can measure what they do directly in terms of page views, engagement, and understanding of their customer base.